Alright everyone, welcome along there. Week 8 extras. So we've looked, haven't we, already this week at maps and what kind of goes in to making them. And the point that I really wanted to make was around understanding that there's layers to maps. So let's cut on over, have a look at some more of the theory on it and see if we've got that all kind of really, get you now, right, which will make it much easier to understand the second part of today, which is where we start to look at then the evolution of maps, which is why I think so many people are interested in things like shape maps. So let's cut an hour and see what we've got going on, eh? Alright, so here we are, yeah? Layers and maps and layers, and what does it all mean for when we actually start to look at what's going on within Power BI and across the Power BI service as a whole, okay? So we've got to get to this clarity in our points, haven't we? That you've got data existing as layers on reference, okay? So you've got a reference plane, which is effectively the map that you see, like on the right hand side, we've got the map that gives us the clarity that that is the USA that we're looking at. Whereas on the left hand side, what we've got is effectively, it's a scatter plot, isn't it, from Sundance. So we can see the difference. We can tell in terms of roughly what's going on in terms and where from the Sundance visual that this is the USA. And that's something that almost everyone I've showed this visual to has got, oh, that's the USA. But it's not, is it? It's just a scatter plot, okay? It's that reference plane that helps us to understand and say, right, I get you now. This is this area of the USA. And it allows us to drill down and actually explore and understand more about what's going on with that layer. So if we look here where we've got the two separated, okay, so I've put the USA as a proper visual. On this side, okay, we can see we've got that reference layer, but we need to be aware, aren't we? And the bit I want you to really get is that at no point in those two, okay, is there actually an interaction, right? The map is there and we're putting a data layer on top of it, right? And I had this conversation actually with my mum yesterday, and she said, oh, so when I go to Google Maps and I do this and that, I was like, yeah, Mum, it's exactly like that. And it is. So Google Maps, Bing search, whatever you want to do, it's the same, isn't it? They've got a reference layer that you're looking at, which is the map, and then they'll overlay whatever it is you've searched for on the day. And it's that ability to overlay on top of a map that is really what makes maps useful as a visualization tool, okay? So we've got the idea, haven't we, that a core map, the core maps that we will use within Power BI, it's the reference layer, and the speed and the performance of the map is down to the pace of deriving the reference layer. So as Patrick LeBlanc likes to say, push things as far left as you can, so as far back into your ETL scripting, if not further to your data source, to actually derive what you need. So if you can build something that's going to give you the latitude and longitude of your locations, so as we say for a retail environment, where are all my shops? If you could put that through so when it comes through, you've got a latitude and longitude, just like we've got in the New York water tower data sets where we've got a latitude and longitude for each building, you will find that's much quicker than building a lookup, especially as you will find you will need to use a multi-layered lookup to actually get the results that you want, yeah? So what we've got here is we've got the same map, isn't it, really, effectively. We've got one on the left-hand side that's doing a state and then a county name lookup, and we've got one using the latitude and longitude, okay? It gives a much clearer picture, I believe, having the latitude and longitude, because I think we can both look at the two and see, well, This one definitely is just the USA, whereas the other one, it seems to have picked up these locations in the UK as well, right? And there's some differences in the density. I'm sure it looks like the latitude and longitude one has placed them all more appropriately. Okay, so we can see potentially there's gaps that will come through because you might not be able to find matches for that information that you have, and that's a truism. That's something that can cause problems. We'll have a look at that again when we go over into our New York water tower data set, where we can really explicitly show that a little bit more, especially when we talk about shapefiles. So really there's a benefit there in terms of, if you know the latitude and longitude, you can always plot it, you can place it correctly. If you have to look it up, you are dependent on that information and dependent on being able to find a match for it. So it will always come down to, if we expand here, how you build your geography for your table, okay? And that's always going to be a problem because it's never, ever going to be 100% perfect. You will find potentially there will be issues, and you'll find that you need to maintain and manage that a lot more, especially as things change over time. So be aware, all right, that, as we say, just click the right button, that keeping that county information there, the latitude, longitude, that they match, those will be things you need to do. Equally, latitude, longitude, you still have things to do. So you'll see if we look at some of our other data sets we look at, so the England food hygiene, seen with that there's just massively, there's some real outliers in the dots where someone's put something in just completely the wrong place. But those would tend to be things that you could actually do some work on. So potentially we'd go back and look at Google Maps or Bing Maps and find, that's the outlying location, let's move it to the right place. So there's things you can do, there's manual steps if you've got something that's massively out, but at least you know, I'm going to do that in the back end because we're building that, as opposed to it being something that's public in the front end where your customers are going to see, oh, well, you told us this was the map of the US, so why have we got places in England? You know, if we zoom in here, we've got Durham County. Well, you know, County Durham's just down the road, isn't it? So we've got a problem. Okay, so let's cut over, see exactly what we mean when we're looking at the next level of this, all right? Because these layers, this reference layer and then a data layer, okay, are you inherently going to have slowness because you've got two layers, haven't you? And you've got your data layer is going to have thousands of points, okay? So if we went back to Sundance here, which we can do in page 1, right? One of the things that Microsoft was showcasing with Sundance is the ability to put lots and lots of information into a visual, right? So this visual actually is using over 30,000 data points. So we've got 30,000 plus dots on the page, right? Whereas we've already had that conversation, haven't we, about scatter plots and visualizations. You have less that you can do. So the bit I want you to look at really is around here, okay? In the Midwest, around here especially, right, it looks more random here, okay? I always think if I look at the Sundance, you can really see roads. I think you can see that counties are along roads in particular, or you can see like trails along there. Like that whole structure is missing from the scatter plots, okay? But they're missing, they're not quite there, and it's because of the capability to put that many dots on a page of Sundance versus what the mapping tools will allow you to do, or even the general scatter plot of Power BI. So it's not the map itself, it's the data layer that's going on with it, right? But what I want to do anyway was let's cut back over to the New York water tower data set and see exactly what I mean, and actually then we'll see how a shape map is built. So we're back to these three, aren't we? Okay, we've got the three visuals here that are useful to see, aren't they? Right, so we've got a shape map, we've got the two main map types, we've got the Azure maps, we've got the Bing maps, right? Honestly, in my professional experience, Azure maps I think are better, but they are slower. Okay, that's my personal view, professional view, whatever you want to say. So it would depend on what it is you're looking to do which would dictate which one you would use. Okay. So what I mean, if I went back to page 1 here, right, where we've just got some charts that we're throwing together, and then we come back, you'll see that the Bing map loads and then the Azure map loads. It's slower. They're both exactly the same, using exactly the same data points. It's slower. The question that you're going to find is, well, what's a shape map? Right? And a shape map does something different. So because we've mentioned before, right, a shape map is a line drawing of data. So it is only a data layer. And we are saying across our data layer, this point, or this shape in our data layer, okay, this is shape map, the shape, right, corresponds to something. So we have a Manhattan. We can kind of say, oh, that's there, okay? But what does that look like when it's being built? Okay? So the tool we use to really ensure that we've got our visuals in the right shape, or our shape maps in the right place, is something called Map Shaper. Right? I'm going to bring that in. Okay, and into Map Shaper, what we will bring a GeoJSON or a TopOJSON or some other shape information that we've managed to find from the internet. So if I import here this information, this is the borough map that we've got. Okay, and we can kind of make some sense of it, because what we can do behind the scenes, obviously these are locatable because these are built using like latitude and longitude coordinates to kind of put them together. So what we can do is we can put a satellite overlay under it. Okay. Let me do this actually. It's easier with this road one, isn't it? So we can zoom in and we can see here are the lines coming through it, the boundaries for something. So it's clearly been mapped that there's a shape to it that it overlays something. Somebody's gone around and worked out where those are. Okay, it's great that I don't have to do that, because my goodness me, you'd end up with lots of straight lines. I wouldn't be doing it as well as they're doing it here. Okay, and this is why it's so difficult to do anything with shape maps. If you have to, you need to kind of go and download them, find the right ones, and we can see how this maps together, and we can then work out, is this correct? Is this going to give us what we need for our business? Okay, and then we clear that. And you can see what you're left with is the line drawing. So we've got these shapes. So what we're effectively doing with a shape map is we are saying, for this shape, how many items do we have? Okay, and what was used is an overdue percentage to dictate the colour. The idea being that the more overdue buildings there are, the more of a particular colour it should be here. Okay, so it's not a particularly great, not particularly useful visual for us in terms of what we're doing, but it's showing this is how it works. So I'm not placing individual things, I'm simply saying, how do we aggregate it? And because it's an aggregation, it is inherently quicker. Okay, but the inherent quickness of it will determined by how many items you have in your visual. Okay? But if you remember what we said earlier in the week, is that you've got potential benefits here. So if we looked at, say, Manhattan, we still have a problem that potentially Manhattan has too many data points, because there are still some 4,000 points that need to be plotted. And these scatter plots that we talk about, these data layers on top of maps, don't really like going beyond 3,500 or so. Okay, 3,000-ish, 3,500. So straight away we've still got that problem that we're going to be dropping some. Our sample set will drop some. So in that point, you might say, well, we need to do more to break down our data points. We've got one that potentially is still an issue. So how could we split those up? So there are these NTAs as well. So we could go back to our map shaper, and if I hit refresh to drop that, And if I bring in an NTA file that I found, okay, we can see, well, we've got these, there's much more. So we have much more granularity around it. And this would be the sort of thing that we would use for the New York taxi data set. So we actually started to piece this together. So there's lots of things that we can do, but you could still say, well, this granularity is too low because we've now got to map all these data points, which is, you know, there's 200 to 300 here, isn't it? I'd say, well, about 100, maybe 150 or so. Should have counted them. So it comes down to how many shapes you've got on your shape map will dictate as to whether you're going to get a benefit from it. Okay, too many and you're going to lose it, because just like in just like if you have to look up your locations, it slows it down. The complexity of the drawing of the shape in your shape map slows it down as well. So you might find that, yes, the pivot table is nice and quick and easy to build behind the scenes. Remember, all Power BI visuals are pivot tables behind the scenes. But then laying that out, putting all those shapes on, colouring them appropriately, slows it down. The last thing I wanted to do is say, well, let's look at the alternative, okay? Because I've got an alternative, right? I could use the filled map and just say, well, the filled map will do what I need. Oh no. Okay. And the filled map, you have the same issue. You have the same challenge with it, okay? So I've put together here the NTA map that I've got, where we've put the NTA codes that we've got, and we can see there's not a full match between the NTA codes and what we have. So I would, in essence, have to go and piece those together and work out, well, what's happened. This one is built from the 2020 NTA names. Potentially I need to use the 2010 NTA names. So I would need to go and get the one from the 2010 NTA names, compare the two, see, do they match, do they not match, have a look, see, potentially even find out ways of piecing together with which NTA code should this go to. Is there a code for these? Do we look in something in the data set to try and piece these together? You end up with quite a significant piece of work to do to match those up. Whereas latitude, longitude, okay? It's one of those things to work through. The other thing with the lookups, so I was looking at the filled map here, is no matter what I've done, it's always just pieced these all together. So I can turn around and say here, this is the borough of Queens, but the way it's built it on my filled map is it's New York. So we're back to the point, aren't we, where trying to build up the right structure in your geography tables so that the fill finds the right place becomes the challenge, right? So you kind of go, which is better, right? And honestly, this is where I struggle, because it's going to depend on your use case. There isn't a recommendation I could say to you, this is the right thing to do. This is going to be use case specific for you. So have a look, okay, and work out what it is you need. But remember, you can use shape maps or shape files for that high level filtering down. So working out what that is, yeah, trying to find the right granularity so that it's easy to identify from one to the detail level that you've got, and think of it more as that drilled down functionality that you need, to then get into the point where we can get the detail. And it's that balancing act that too detailed a shapefile makes it slow and slows down your visuals, but you want it to still have the impact that you need for your people to see and assess what's going on. So what do you reckon then? Okay, shape files are great because they remove the reference layer. There isn't a reference layer in a shape file, in essence. Okay, it is just a data plane. Because it's just a data plane, you're not actually tied to maps. Okay, and there's other stuff. So you can use SVG files as a different visual. It's not the shape maps, it's something else. Place SVG information in, and that makes a big difference as well. So you can actually start to visualize your processes. Use a tool called Inkscape. It's open source to start to piece those together. And you can actually get some really nice visuals out doing something like that. But it all helps if you've understood the concept of a shape map, that it is a visual layer, it is a data plane only, there is no reference layer. So we looked at Sandance, didn't we, which was just a data layer as well, to kind of really get our heads around the idea that a map is a reference layer with a data layer on top. The Shapemap is obviously the better one because it is just that data plane. So because it's just a data plane, if we simplify it and make it nice and easy, it will give us a really punchy set of visuals that we can then drill down on to get the data detail that we need for the next level of our analysis. And that's one of the benefits that we get with Power BI, isn't it? We've got all the layers that we go through. So we've got the data, the presentation layer, you've got your tooltips, which sit above that, and then you've got drill through or drill down, which goes deeper down and gets the more detail into it. So we can use latitude, longitude, use our tooltip to actually start to express the data about the building in our New York water tower information. So we're not looking at just latitude and longitude. We can say, oh, this is building X that does blah, blah, blah. We could do other things to piece together what that is. You know, if it was our retail environment, we say this is this store, this is its most popular item, this is the highest sales agent we've got, or whatever you want to do. Okay? It all works, and it's all about understanding these concepts of layers and how they are all going to interact together. So I hope that's helped. Have a great weekend. Stay safe. Ta-da.